Hello everyone. We'll work on Leetcode 1373, the maximum sum BST in binary tree. Let's first see what this question is about. And I think this question doesn't explain very clearly what it actually needs us to calculate. So we're given a binary tree, and so for every root and its subtree, we can see if that tree is a binary search tree. So if that's a binary search tree, this question asks to get the summation of all the nodes in the binary search tree. Then you need to compare all the sum, then returns the maximum sum. Okay, and the definition of BST is the same as in textbook. So the left subtree with max value should be less than the current node's key, and the right subtree, the lowest value in the right subtree should be greater than the current node's key. And also both the left and right subtree must also be the binary search trees. So it's a recursive definition. Let's work through this example one to get an idea. So for example one, let's first look at this node. And this is, of course, not a binary search tree because we have a 4 here. It's greater than 1. It's not less than 1. So this is not a BST. How about this tree? This tree is also not a BST tree because we have a node 4 here. It's identical, but it's not greater than 4. You see, it should be greater than the node's key. So this is not a BST. How about these two leaf nodes? Every leaf node is a BST based on the definition. So we have this node, all the node sum of this subtree is just 2. It has only one node. And for this, it's 4. Okay? Then we can see this part. Yeah, and based on the definition, you will see this is a BST because its subtree is also a BST, and the largest number is 2. And this is also BST, and the largest number is 6. The smallest number is 4. It's larger than 3. So this is a BST, and the node summation is 3 plus 2 plus 5 plus 4 plus 6, which is equal to 20, right? So we have 20 here. And then this tree is also a BST, okay? So its summation is 2. And 5, 4, 6, this tree is also a BST, so the summation is 16. And this is also a binary search tree is 4, and this one is also valid, it's 6. We have 7 BSTs, 7 numbers. Each one is the sum of that binary search tree's all the nodes. So we get all of them, then get the max equal to 20. And 20 is the number we need to return. Okay, so how to solve it? The way we solve it is actually recursion. We define a recursion called DFS, and we make it return something called node. And this will have input root, and then we will return a node, and node is a structure. Say struct node, and each node will need to contain the sum and the min and the max, because each subtree has its own node, and the node sum is the sum of all the keys in this subtree, and min and max are corresponding to the minimum number and maximum number in this subtree. Then we have need to define the constructor node int sum, int min, int max. So it's sum, min, max. Okay. Then we will define the answer. The answer is the lowest number for answer is 0 because based on this example, we have the right to select 0 trees. So then the minimum number is just 0. Okay, and suppose we have this DFS, then we do DFS on root and return answer. Then we will implement this DFS. So we will first define the left. How to initiate these 3 values for left? I think sum is pretty clear, it's 0. And what will be minimum number? So the minimum number is something we wanted to work when the left node is null pointer. So if that is a null pointer and we want to get the minimum of this tree root, it will return the root value, right? So we will let the root value to be the minimum number of this virtual left node. Then the right value is negative infinity. We'll define negative infinity here. It's just 1e minus 8. How many nodes do we have? Okay, we have 4e fourths nodes. Oh, 4e fourth nodes. And also 4e4 value. So we actually need something like 1.6 E8, right? Plus something, 10 maybe. Okay, this is if, and we need to have right. So very similar. Right is this number. The maximum of left is negative infinity because we want it to be to max every time. And this is similar. We want it to decrease every time. And if the root has left child, left equals to DFS root left, and if root has right, right equals DFS root right. Then we will need to consider whether the root tree is a binary search tree. So if there are 2 conditions, right? Left max is less than root val, and root val is less than right min. This means the tree root is a BST. Then we get the sum. It is left sum plus root val plus right sum. Okay? And then we will return. We will update ends, max s and s, and we will return node. Sum is s, and the max number, the minimum number is left min, and the largest number is right max. Okay, and if the tree root is not a BST, the tree root means this tree. Okay, it's a variable name, root. Then we will return something that doesn't affect our result. So the sum will be negative infinity. Okay, because every time we want the maximum sum, so negative infinity will not change anything. The left minimum value will be minus infinity, and the maximum value is positive infinity. Okay, let's see. Okay, it seems it's working. Let's submit. Okay, and I think that's it for this question. The key idea is, the key difficulty is to understand with what this problem is asking for. And the second is we are using recursion But for recursion, we need to return three things together. And how to define these edge cases is a little bit tricky, and you need to have an idea of how this whole algorithm work. The idea here is for left and right, you are initializing those values to make sure that if the left is a null pointer or right is a null pointer, these values will still work for your algorithm. Then that's the value of for the edge cases. Okay. Then I think that's all for this problem, and thanks for watching. See you next time.